Welcome to Semaphore Uncut. Today with us we have Matt Klein. Matt, thank you so much for joining us. Please go ahead and introduce yourself.
Thank you for having me. So my name is Matt Klein. I'm a software engineer at Lyft, where I have worked for the last 4.5 years, mostly on infrastructure network technology. I've spent pretty much my entire career working on low-level technology like hypervisors, operating systems, distributed systems, networking, performance, those types of things. For the last 4.5 years, I've been working on open source networking technology called Envoy, which has become quite popular. So these days, I split my time where I spend about half of my time working on Lyft-related problems around reliability and networking and distributed systems. And then I spend, about the other 50% of my time doing industry work around Envoy, open source management, those types of things.
Okay, great. And can you give us an explanation of what is Envoy?
So Envoy is a software load balancer or a software network proxy. So at a super high level, that's a piece of software that will take network requests. Those might be TCP connections or they might be HTTP requests. And it will do various things to those connections or requests as they transit that proxy. So that might be observability, like stats, logging, and tracing. It might be load balancing. It might be things like timeouts and circuit breakers. So there's a whole wide variety of things that a network proxy can do. So for those of you out there that have heard of other software proxies such as Nginx or HA proxy, Envoy would be most similar to something like Nginx or HA proxy.
Okay, that's great to have that comparison so we can grab onto something. And Nginx is probably something that a lot of people know about. You mentioned it's 4.5 years. And when you initially kicked off the project, was there a concrete pain point that you wanted to solve? Because, Envoy is solving a whole class of problems.
Yeah, that's a great question. So when I joined Lyft, again, this is about 4.5 years ago, I came from Lyft from Twitter. And Lyft was very early in its monolith to microservices journey. So at that time, we still had a monolith that was, written in PHP, and we were using MongoDB as our database. And it was a fairly simple monolithic architecture. And I'm using simple in quotes, just in the sense that even in a monolithic architecture, you're still running a networked distributed system. There's a load balancer, there's a monolithic application, there's a database. So even in that very simple state, you have multiple network hops. There are things that can start going wrong. So when I came to Lyft, we had, I think, something like 10 or 20 different services and the monolith and all of the problems that you see really everywhere these days that, any organization is trying to roll out a microservices architecture. And that primarily boils down to problems around networking and problems around observability, just in the sense that very hard to debug tail latency issues, very hard to understand where is a problem occurring? Is it, in the application? Is it in the virtual network? Is it in the physical network? Is it a hardware problem? And I've seen organization after organization, have trouble with this migration, just in the sense that, the organization starts getting stalled because they don't trust the microservice architecture because they don't understand, where the problems are happening and how to actually debug them. So to get back to your question, really the primary thing that we were trying to solve initially with Envoy was around observability. So 4.5 years ago, where Lyft is entirely based out of Amazon Web Services, we were using elastic load balancers for load balancing. And 4.5 years ago, ELBs at that time did not support percentile latency metrics. So, something that most developers today would, really take for granted from a network observability system, being able to observe, P50 latency or P99 latency. At that time, ELB and CloudWatch didn't support that. So that's just one example. And in general, it was a black box. So it was very difficult to understand what was going on. So Envoy's initial use case was actually as an edge proxy, and it was, to give richer logs and richer stats and metrics so that developers could understand what was actually going on. And that was based on experience from back at Twitter. So at Twitter, I had worked on a proprietary edge proxy system, that was providing similar types of features. So advanced observability, things that most of the solutions that had existed at the time did not support. So you're correct that today Envoy supports an absolutely incredible amount of features. But, at that time, it was mostly observability was the main focus.
Yeah. I can just add to that. And as we were translating from our monolith to microservice architecture, observability was something that struck us out of nowhere. Previously, we kind of were able to learn a lot about our monolith. But moving to microservices, there is that layer of network. That network just becomes, everywhere in almost all the requests, and depends on the teams and the maturity level of the teams. But we were definitely not ready to tackle that.
It's a super interesting thing because I think what you're seeing right now is, in the last couple of years, there's a lot of buzz around this, thing that people are calling service mesh, and then there's a lot of backlash around service mesh complexity. And I've written about this on Twitter, but, the honest reality is that if an organization is committed to moving to a microservices architecture, there's a set of problems that have to be solved. And they're complicated and they mostly revolve around networking and observability. And again, those are things like stats, logging, tracing, service discovery, load balancing, all of these things. And you can potentially solve them with writing a bunch of code and putting it into a library or writing it into every service, or you maybe can look at the sidecar pattern. But, call it what you want. There's a bunch of problems that end up having to be solved.
Yeah. And maybe in monolith, you kind of have to solve it once in terms of those relatively simple things like timeouts, retries, and all that. So it can be maybe a single library with a single code base.
Yep.
And with microservices, then you need to solve that in various languages, in various places, and update that library in various places.
Yeah. And if you look historically at companies, I think that have spearheaded some of the microservice architecture work, and that would probably include Amazon, Twitter, Netflix, at least companies that have been very public about what they've done. Most of those companies, actually, if you really dig down, they grew during a time in which they basically used Java. Like Java was the language that was used. And if you're an organization that's lucky enough to use a single language, you can invest in Netflix has Hystrix and Twitter has Finagle and Amazon has internal libraries that do very similar things. But most modern companies, for better or worse, they're what I call polyglot. They have multiple languages that are in flight, whether that be Java and Go and Rust and C++. And then now you have to choose between effectively re-implementing and trying to normalize all of these things in every language, or you can try to use some type of client-side load balancing proxy. But at the end of the day, the problems have to be solved. There's no easy way out. It's either stay with the monolith. And what I tell everyone is stay with the monolith as long as possible. And, when the monolith doesn't work, typically for human scalability reasons, and it's time to go with the microservices architecture, well, then there's just a set of problems that are going to happen. And 10, 15 years from now, hopefully it'll be a little more magical. But unfortunately, we're in this intermediate time where it is not so magical right now.
Yeah. It's like one of those quotes that I cannot quote, but it's better to join the revolution a bit later.
I'm a perpetual late adopter for that reason. I like other people to solve my problems for me.
I agree. Okay. Yeah, something that seems that you're just shipping based on your Twitter, it's Envoy Mobile.
Yep.
So it came from the community, or?
For those that are listening that don't know, Envoy Mobile is the idea that we're going to take the Envoy proxy, so the proxy that we run server side, and we're actually going to run it on phones, so on iOS and on Android. And, for those out there that might think this is absolutely insane, there's actually quite a bit of precedent here from large companies. So Facebook has done this for years. They have a library called ProxyGen, which is the library that they build all of their backend servers on. They actually use that same code on their mobile clients, primarily to give consistency. And Google has done this for a long time also. So they take their open source Chrome code and they have a library called Coronet, which essentially bundles this Chrome networking code across Android and iOS. And you might ask, why are these companies doing this? Like, these are two major companies that really have valued mobile first architectures. They're doing this for the same reason, that you might investigate a sidecar service mesh pattern, which is that this code is incredibly complicated. So why would you want to re-implement it twice, when 99% of the code is the same around how you handle retries and, back off and, advanced protocols like QUIC or HTTP3 or TLS 1.3. It doesn't make a lot of sense to re-implement it multiple times when you might want to pay a few people to be experts in that code, and then they can work across server and mobile. So when we looked around the industry, none of Facebook's actual code has been open sourced. So that's not a solution that is readily available. The Coronet code is open source, but it's a fairly low-level library that's been embedded in a bunch of larger code that is not, I would say, very easily end user accessible. So it's mostly Google applications that are using it. A couple of larger companies have learned how to, tease that code out of the larger Chrome code and use it. But we felt that there was a real opportunity here to have a true end-to-end solution. So Envoy on the edge, Envoy within the mobile application. And then we really have a holistic networking stack that can span, the server edge to the mobile edge. And there is just an incredible amount of work that can be done here, both in protocols like QUIC and HTTP3 to reduce latency, to various types of load balancing, to analytics and debugging. And again, we just feel that we can do a bunch of this in one place, right, from that lower layer. And then there's a higher layer thing that we find very interesting, which is that, in general, the industry, at least larger companies, are moving more towards IDL or interface definition language-based APIs. So things like protobuf or gRPC. And those APIs have a really interesting property, which is that you can have annotations on the APIs that do different things. So whether those be caching or, basically specifying that an API is only called in high quality network environment or, doing deferred or offline APIs. So these are things that we think could be done as annotations, and then they can just be transparently implemented in the underlying networking layer and have that be consistent across iOS and Android and the backend. We are very excited. We reached a milestone last week, which is that the team got the library actually working on iOS and Android to the extent that they took Lyft rides on both platforms, which means that it's becoming real. So we are making great progress. I'm very excited.
Yeah, it's great to hear. I never myself ventured in the area of mobile development, but I heard from people networking problems there can be very, I'm going through a tunnel and, my video stream should continue and changing those cell towers and, a number of things that we don't face in our Kubernetes cluster.
Yeah, it's a very rough environment. And many applications, they're increasingly becoming mobile network dependent. And actually, if you look at an application like Lyft, it has, I would say, some of the more stringent networking requirements in the sense that if you think about where many Lyft rides are taken, they're taken in what we call dense urban canyons, with lots of buildings. And those buildings tend to have not very good networking coverage. So the network can be very spotty. So really trying to work through how to have the most efficient edge networking there is a very difficult problem. And if we're going to invest in it, it would be great if we can invest in it once and not have to re-implement it multiple times.
Yeah, for sure. Yeah, there is Envoy Con, which is coming. I haven't wrote down exact date. Maybe you can share that with us.
Yeah, it is the day before KubeCon. It is November 18th. We published the schedule. I think it's going to be a fantastic conference. So for anyone that is coming to KubeCon and wants to learn more about Envoy, we did our first conference last year and it was fantastic. I'm very excited for this year. So I'm pretty confident it's going to sell out. So I would grab your ticket.
Yeah. That was actually my next question. I know that last year's conference was sold out super quickly. So I wanted to ask, is this one already sold out?
No, it's not. We have a bigger venue this time. So hopefully we can fit more folks, but I'm pretty sure it's going to sell out. So I would definitely get a ticket if you're interested in coming.
Yeah, sure. So moving forward, I have a list of kind of low-level technical questions that I'm personally interested in, and I hope that our listeners would be also. We heard that the first line of code was written like 4.5 years ago. And starting the Envoy today, would you still write it in C++?
That's a tough question. I don't think it's as much of a slam dunk today. If I were starting today, I would strongly consider Rust. That's probably the only other language that I would consider. The Rust ecosystem is increasingly getting more mature. Like we already mentioned, I'm a pretty late adopter. So I would say that community and the ecosystem is still not quite as mature as I would personally like to see for a product that I'm trying to make rapid progress on. But I think it's much less cut and dry today than it was 4.5 years ago. I think 4.5 years ago, it was still a no-brainer just based on the technical landscape at the time. But today, I would have to think pretty strongly about whether to use Rust or C++. I don't think our velocity is really slowing because of it. I think when you talk about programming languages, particularly in the, social media, Twitter bubble, it can be a little skewed what the actual reality out there is. There's still a lot of people out there that are very highly competent C and C++ programmers, so orders of magnitude more than Rust programmers. So it's mostly, for me, it's just trying to make progress as fast as possible.
Yeah, I agree. It's hard to form the good opinion just by listening to Twitter or Hacker News or similar sources. Yeah. Okay, and getting into the architecture of Envoy. So I heard you mentioning some of your previous interviews. One difference between Nginx HAProxy that you have mentioned is that they rely on flat file configuration, while Envoy was made in a way that it's API configuration driven. And now looking at Kubernetes makes a lot of sense. How did you came to that?
I think a lot of that was honestly just previous experience. So, there was working on related systems back at Twitter. Prior to Twitter, I worked at Amazon. I worked on EC2 networking. So, I've been working in large scale, internet distributed systems for 10 plus years. And I think the biggest realization that I've had over the last 10 years is that in these highly dynamic environments, whether they be Kubernetes containers or auto scaling or just like really any highly dynamic environment, the biggest problem that people face is it's essentially software entropy, So it's trying to make sure that everything stays up to date. So I've just learned in my career that, generally attempting to take an eventually consistent approach and essentially take an approach where you have a target goal state and each entity is trying to, get up to date to that goal state. You try to limit the amount of software that actually has to be deployed to each host. It's just vastly simpler from an operational standpoint. So, I think I knew that going into Envoy, and we knew that in general, for most changes, we did not want to ship files out to hosts because, you talk to anyone in the industry who has been involved in shipping config files out to whether it be proxies or any other software. And it's a pretty horrible thing. Like, it's just not good. So we really wanted to avoid that. Now, to be clear, in Envoy's first version, it basically supported one API, right? I mean, it supported just a host or an endpoint discovery service. Now we have tons of eventually consistent APIs. But it was really that idea from the beginning that we cannot be shipping files out. It's not scalable. It's just not operationally sensible. That was where that started.
Okay, yeah. In this same area of architecture of how Envoy is made, I read somewhere that plugin architecture is one of the reasons why adoption was very strong and so on. And you mentioned that on various levels, it's possible to write plugins and extend the system. Can you maybe walk us through that? What are those levels and how that works?
Yeah. So, and again, like the APIs, Envoy started with only a few extension points, and now we have many. So those are primarily around filters. So being able to, filter HTTP traffic and either do buffering or rate limiting or those types of things. We can also filter at the L4 or TCP level. And these days, we have extensions for access logging and stats and retry policies. The list just goes on and on and on. And, one of the main reasons for extensibility, it's mostly related to open source sustainability. With an open source project, particularly with one that is very popular, it's impossible to make everyone happy. There's always someone that's going to come in and say, I want to do X, or I want to do Y, or I want to do Z. We've tried strongly to never say no to a feature request. But we don't necessarily say yes. And what we will say is either, okay, this is a generally useful feature, let's put it into the core. Or, this seems very specific to your use case. Either there's already an extension capability here, you can go use this, or why don't you build a new extension capability into Envoy, and then you can build your use case into this extension capability. And that, I think, is how we've been able to scale the project, because the amount of use cases that Envoy is used in today is absolutely staggering. I mean, it's like I'm always talking to people that are using the software in pretty incredible ways in a very short period of time. And I think it's because, in general, we've tried to allow organizations to unblock themselves. If they really need to do something that the core software doesn't do, they can write an extension, that will help them do that.
How are those contributions going? Are there people who never before developed in C++ who are also contributing extensions, or?
To be honest, I don't track in depth. There's always the occasional grumbling, I don't know C++, I can't do X, Y, or Z. But to be honest with you, again, the growth of the project speaks for itself, right? There's enough people out there that seem to have no trouble doing what they need to do. I mean, the growth of the project has been astounding. So when I look at it that way, I don't really see any problem. And it's not that C++ is the only way. Like, we do support Lua scripting. So particularly for HTTP filters, I think a lot of people have been able to solve the problems using Lua scripting. Google is working on WASM support now, and I think WASM is going to be interesting because the WASM support will support extensions in a variety of different places, and WASM is going to allow people to write extensions in Safe, C++, Rust, Go. I'm not actually sure which languages they will support, but I think, WASM is the future of Lua. Like, Lua is basically a dead language. So I'm excited about the forthcoming WASM support. So, I think we're cognizant of the fact that we want people to be able to write extensions in a safe way and not struggle with it. But, technology is what it is. I mean, you move forward pragmatically, I guess.
Yeah. It's obviously very successful open source project. And maybe you can share a bit of how a life of a maintainer of a very popular open source project evolves and how it changes and how it is day to day.
Sure. I think many people out there think that my life is a lot more glamorous and exciting than it actually is. So we open sourced Envoy in 2016, September, I think 2016. And 2017 was by far the toughest year of my life so far, professionally. And a lot of that was just, coming very close to total burnout, right? Because we open sourced this project. We had a small team at Lyft, but primarily I was still writing most of the code. I was answering almost all the questions, fixing the bugs, and it was bad, and a lot of open source maintainership, particularly with the way that the economics of open source work these days, is many maintainers find themselves in, I would say, odd relationships with their employer, in the sense that the maintainership work is not clearly specified in terms of what percentage of their job is actually that work. So in 2017, I was effectively doing 2 jobs or 2.5 jobs. I'm working at Lyft. I'm like trying to grow the project. It's like a startup that's exploding. And it was difficult. I struggled during that time. And most of what I did during that time was try to grow the community, try to grow the maintainers, grow the contributors. And, very early on, we had people from Google and Apple and a couple other companies that started to become maintainers. But a lot of that was me, trying to nurture that and try to have a place where people were excited about actually doing that work. So through 2017, that was a very difficult time. Things have gotten significantly better since then because, I've been working very hard at essentially making myself expendable, so like growing the community, growing the contributors, growing the maintainers. And now, we have a whole ecosystem of companies that are building products on top of Envoy. We have maintainers, Google does a ton of work, and then the rest is sprinkled, across a bunch of different companies. We have people in the community, they answer questions for other people. But all of that takes nurturing. And, for me these days, I don't get to write a lot of code anymore. I do a lot of code reviews. And I do a lot of boring things like trying to make sure that our CI is, paid for and organize EnvoyCon. And things that are important, but, it's not writing code. So I think the way that I talk about it these days is in some ways, I feel like I'm the CEO of a increasingly large company. No one actually works for me. So it's kind of chaos, right? That's like the only way that I can describe it.
It is a very good explanation. It is, as you said, a big and growing community with a lot of maintainers. In this, I would say, mature stage of an open source project, how do you handle decision making on what are the next features that are going to be merged into the core, and how are you managing that?
So far, we've been able to stay fairly nimble. And, for an infrastructure software project like Envoy, we are very odd these days in the sense that we are a true community-driven project in the sense that people show up and they do features and that's how they get merged, right? And most infrastructure software projects these days, the vast majority, they're driven by the major cloud providers or by a venture capital-backed startup. And when you have a single entity that's effectively driving those projects, they can have product managers and a roadmap and all of those things. So, people are always asking me for what is the Envoy roadmap? What did people do in the last year? And honestly, I tell them, I don't know. We move the ball forward, if we're using football terminology. Like, I'm not sure what to tell people. It's like we don't have a community manager. We don't have a product manager, so we move forward. In the history of the project so far, we have not had a major disagreement among the maintainers. And I'm sure it'll happen eventually. But I think it hasn't happened because we've been very careful about who becomes a maintainer, making sure that we see eye to eye on philosophy. And the other reason why we haven't had a lot of disagreement is what I talked about before, which is the extensibility. It's a way of allowing people to push their site-specific needs into extensions so that we can focus on the core. And what that ultimately means is that, Envoy is a Swiss Army knife. It's not necessarily even accessible, I would say, to the average user. It's a very complicated piece of software, which is why these days you're seeing it bundled. And there's some new Envoy related thing that's announced, I feel like every couple of weeks, but it's being bundled in a separate piece of software in which people may not even be aware that Envoy is there. So I think that's a happy place to be. I think for me and the project, it's more of a plumbing piece. And I think it makes it a little bit easier because we can focus on keeping the core project sustainable, making sure that we have the right extension points, and those types of things.
Yeah, I understand. It's great to hear that plugin architecture is also something that you can use as a tool for generally managing the community. And
yeah, I would say that's its biggest benefit. Yes, it's great from a software engineering standpoint, but its biggest benefit, in my opinion, is keeping the project sane because it's an escape valve that allows us to say to people, this is too specific, but we're going to let you go and fix your problem some other way.
Yeah. Okay, so thank you, Matt, for joining us, and I think it was a great conversation. Yeah, good luck with EnvoyCon. As you said, it's going to be great. So yeah, I'm also inviting people who want to join. And of course, good luck with project. And yeah, thank you.
Great. Thank you so much for having me.